This will give you an idea of the relative contributions of different ions to the resting membrane potential. So we have an unequal distribution of ions across the plasma membrane. We have large quantities of sodium outside the plasma membrane. In fact, we have 10 times the concentration of sodium outside the plasma membrane than we do inside. The reason for this, as you remember, is that sodium can't cross the plasma membrane without some kind of intervention, for example, an action potential. So the membrane is relatively impermeable to sodium. Conversely, potassium, we have a 20 times increased concentration of potassium inside the cell than we do outside the cell. As you remember, potassium can flow relatively freely across that membrane. The membrane is relatively permeable to potassium. So you see there's a lot of potassium inside. It wants to move outside because there's a lower concentration of potassium outside, so it wants to go with the concentration gradient. As potassium moves outside of the cell, though, the cell becomes more negative. Consequently, potassium with its positive charge will be drawn back into the cell. You also have higher concentrations of both chloride and calcium outside the cell, although you do have some organelles inside the cell that have high concentrations of calcium. You can imagine then, and you'll see this again, is that the ion that contributes most greatly to the resting membrane potential is that ion that's able to travel freely across, and that would be potassium.